For a long time, the future seemed guaranteed to know more than we do. Better instruments, better measurements, better answers. Then something refused to behave the way it was supposed to. In 1998, astronomers tracked distant Type 1a supernovae. Explosions so bright they could be used to measure how the universe changes over time. The expectation looked simple. Expansion should be slowing down. Instead, the farther they looked, the more the observations drifted away from that prediction. The universe was not easing its expansion. It was accelerating. That change appeared first as numbers on a page. Then it became something harder to ignore. The map of the observable universe was no longer evolving the way earlier astronomy expected. The future was not just revealing new information, it was beginning to reshape what information would remain available at all. Because some parts of the universe are already moving toward a future where they cannot be reached at all. And the question is not what we will discover next. It is what might disappear before anyone gets the chance. Look up at a distant galaxy through a telescope and nothing seems wrong. Its light still arrives. Its shape still hangs in the darkness. It appears to be exactly where it has always been. The natural assumption is that it is simply far away. But distance is no longer the whole problem. As the expansion of the universe accelerates, many galaxies are moving toward a future where reaching them becomes permanently impossible. They do not explode. They do not suddenly vanish. They remain visible while the separation continues growing. At first, it sounds like a transportation problem. Then the sky itself begins changing. The same process that pushes those galaxies beyond reach also pushes them toward a future where their light no longer remains part of the observable sky. One by one, observable structures disappear from view. The change is not dramatic. No cosmic alarm announces the loss. The sky simply contains less than it did before. A civilization living far enough in the future could look upward and find fewer galaxies than we can see today. Another civilization even farther ahead could inherit a sky emptier still. The galaxy still looks permanent. The opportunity to observe it forever does not. Even visibility has a deadline. And once something disappears from the observable universe, it takes more than a destination with it. It takes information that can no longer be recovered. Imagine a civilization living billions or even trillions of years from now. They build observatories larger than anything humanity ever imagined. Their detectors become more sensitive. Their measurements become more precise. They collect data for centuries and process it with machines far beyond anything that exists today. So the problem seems solvable. If galaxies become difficult to observe, build a better telescope. If signals become faint, build a more sensitive detector. If the universe hides something, develop a smarter way to find it. Normally, a missing answer becomes an engineering challenge. Their scientific abilities might surpass ours in almost every measurable way. So the conclusion seems unavoidable. Better technology should mean better knowledge. Whatever appears difficult today should eventually yield to better instruments, longer observations, and more advanced science. At first glance, there seems to be no reason the future should know less than the present. The only remaining question is whether every problem can actually be solved by looking harder. The flaw in that assumption appears when future astronomers finally point those extraordinary instruments toward the sky. The telescopes work. The detectors work. The science works. But there is less left to observe. The distant galaxies that once filled the observable universe continue disappearing from view. The signatures of cosmic expansion become harder and harder to find. Every generation builds better tools, yet the sky provides fewer clues than before. The response seems obvious. Search deeper, measure longer, increase sensitivity. But each improvement runs into the same problem. You can amplify a signal that exists. You cannot recover a signal that is no longer there. The problem does not go away. A future observatory may scan the heavens and find only the structures that remain locally visible. The wider pattern that once revealed a changing universe no longer presents itself in the same way. Then another clue disappears, and eventually another. Even the cosmic microwave background, one of the most important observational traces of cosmic history, fades from practical observation. Not because anyone forgot how to look, not because technology failed, but because the evidence itself left. That is where the problem changes completely. Intelligence cannot study evidence that no longer exists. A civilization can become more capable while inheriting fewer clues. Over time, the record itself begins disappearing. And once pieces of that record are gone, an unsettling possibility emerges. Some conclusions about cosmic history may become impossible to reach, no matter how advanced the observers become. The consequence becomes impossible to ignore. A future civilization may stand at the peak of scientific achievement. Its instruments may be more powerful than anything humanity will ever build. Its understanding of physics may be deeper. Its calculations may be more precise. Yet when those astronomers look outward, the universe presents a different picture than it presents today. The evidence that once pointed toward a larger cosmic history is no longer visible in the same way. The clues have faded from observation. The record has thinned. What remains is not necessarily a universe that is harder to understand. It is a universe that reveals less about itself. The implication is difficult to escape. Scientific progress does not guarantee unlimited knowledge. Progress can only work with the evidence that exists. When the evidence disappears, some conclusions disappear with it. A civilization born in that distant future could possess greater technology and still know less about the origin and history of the universe than humanity knows today. Not because they failed, not because they stopped looking, because they arrived after part of the cosmic record was already gone. Right now, the sky still contains the evidence. The distant galaxies are still visible. The larger pattern can still be measured. The record has not disappeared yet. Humanity may exist during one of the last eras when the universe still reveals enough of itself to explain where it came from.